Okay, in this video, I want to discuss transesterification. So, transesterification. This is just going from an ester to an ester. Really that simple. We're just changing what our ester looks like. So if we had an ester that looked like this, and we wanted an ester that looked like this, we would use these reaction conditions. So from this ester to this ester. Specifically, we'd be using, what would that be? That would be our alcohol we are using, but let me keep discussing this. So this needs a catalyst. So catalyst needed. One typical catalyst is an acid catalyst, and that would be HCl. And when we want to go from this ester to this ester, we're going to need to use an alcohol. So we're going to need we can use an acidic catalyst and an alcohol. So alcohol, depending on what type of reaction conditions you have to use to get from here to here. So from here to here, you would need an alcohol that looks like this with HCl. So let's actually do that mechanism so it makes a lot more sense on how we go from one thing to another. Let me erase all this. Okay, so we are starting with this ester. We are going to use this reaction conditions to end up with an ester that looks like that. The first thing that happens is our alcohol will be protonated by this acid. So that is just simply HOH. This is protonated. This alcohol is protonated by our acid. The next step would be for this lone pair on this oxygen to attack one of these protons, shift those electrons back onto the oxygen to give us an intermediate that looks like this with an OH positive. Okay, and now our alcohol will do an attack. Since this carbonyl is more delta plus because our proton has been added to this oxygen. So the next step is for alcohol to attack. So HO will attack right there, shift those electrons onto there. We'll have our OH, then we'll have our new ester that we're trying to make, our alcohol attaching, which would be, I'm gonna run out of room. I need to fix this. So our OH, because our pi bond broke, and then our alcohol that attached, which is OH with a positive formal charge. And now what we're going to do is a proton transfer. And the way which oxygen we're going to use the proton transfer with is this guy right here, because we want to get rid of this ester to make this new ester, and our new ester is going to be right here. So let me circle these so you know what I'm talking about. So we want to get rid of this group right here. So that's what we're going to do our proton transfer. So we're going to use a lone pair. So let's just color like this. Use these lone pairs to take a hydrogen, a proton I should say, shift these electrons onto the oxygen, and then we'll get a, let me change the color. OH positive and OH, an O with our new ester, what we're going to make. This is where our new ester is going to be. And our next step is to use these lone pairs on this oxygen to reform this pi bond and kick off our old ester, our old oxygen that made that ester group. And that will leave us with an O to an H plus. We'll also have an alcohol because these electrons are being shifted onto this oxygen. So we would have a methanol. So this is methanol. The last step would be to use another molecule of our alcohol, which would be HO. We would use a lone pair to just deprotonate this hydrogen, shift those electrons back onto that oxygen, just to give our final product to look like that, which is what we have up here. So that is the mechanism for transesterification. If you have any questions, please feel free to leave a comment down below. Like this video if it helped you, and subscribe. Thank you for watching.